Hello everyone, Sen here. On today's video, we're going to be having kind of a miscellaneous episode where we approach many small things that I've been thinking about, and I don't find the right episode to do them, so we're gonna do them now. So the first thing is I want to add an FPS limiter to our game because right now, let me run the game from Steam. You may ask why running the game from Steam. And we're doing that because Steam provides an FPS counter, and that's pretty useful. And it's pretty small, so you may not see it, but I'm running the game around from 14 to 22, 2400 FPS, which is too many FPS for our game. And what this is causing, which is basically the big problem, is our game to be using from 5 to 20% of our CPU, which doesn't make any sense for a game like this. But since we're just running our game with uncapped FPS, that's what happens. So yeah, you can see we're getting up to 20%. What we want to do is add a limiter to our FPS. So let me explain how are we going to do that. First, we want to go into our iterate.c. On here, what we're going to do is just have a new function that we are going to call, we can call it whatever we want, and it's of type void. We can call it app wait for frame. Next frame, which takes the app state as an argument, so we can just have it here. Perfect. And we want to do one thing that we have here. We want to copy this line here. So let me copy it and we paste it here, so we can use the values of the app state variable on this function. So it's super easy to add this FPS limiter. What we want to do first is define how many FPS we want. So we can just define target FPS 144. I'm just saying 144 because that's the refresh rate for my monitor, but you can set it to whatever number you want. And then we want to define another variable called target frame time. That's correct. Which basically is going to be how many milliseconds, like how many, like every how many milliseconds we need to have an FPS, a frame, so we can reach our target FPS. So we just divide our target FPS between 1000, and we know how many milliseconds have to happen between each frame. So with those two things in mind, we can just create a new variable that we're gonna call frame time. Is this variable is of type uint 64, and it's the result of just subtracting these two things, SDL3 and not last tick current tick. So what is this? If we go back to our app update, you will see that here we run our code, and then we get here state current tick equals SDL get ticks. So if you don't remember, this is the number of milliseconds since SDL library initialization. So basically a set amount of milliseconds. And then we run all of our code, we update all of our entities, we render all of our entities, and then after all of that, after we run all the logic for our frame, we come here and we subtract these two things. And this gives us how much time did these frames take to execute. So imagine if the initial tick was, let's say, 1 millisecond, and then we run SDL get ticks and we have 4 milliseconds, we know that frame time is 3. And what we're going to do now is just have an if statement here, which basically says if frame time is less than target frame time, so let's say our target frame time is 6 milliseconds and our frame time is 3, we know that those 3 milliseconds that are left, we want to wait. We don't want to do anything. So what we do is just, we call this SDL delay, which basically waits a specified number of milliseconds before returning. And we pass the subtraction of those two variables. That way, if our target frame time was 6 and our frame time was 3, we know that we have to wait for 3 milliseconds. This is not going to yield like super precise results, but it's going to work for us for now, because we don't need that much precision for now. So we basically need our game to not run at 2000 FPS. So now we run our game. I don't get the FPS counter because I only compiled it. We go to Steam here, we open the game, and now you'll see that instead of running the game at 2000 FPS, we are at 144, 150. It's somewhere close to our target FPS, but you can see that sometimes it goes above it. So yeah, that's not perfect, but it will work for now. So now that we have that, yeah, we have our FPS limit, we can just jump into the next thing, and that's the entities. If you remember, we have a create entity, a delete entity, and a swap entities functions, and they're good, but the problem with that is that we are defining each entity as an index in an array, and then if we swap the entities array around with this function, for example, the entities the index changes. So it's pretty hard to keep track of all the changes and knowing where in the array is the map, or where in the array, when we get more entities, is set entity. So what we want to do is being able to have names for each entity and being able to find our entities by name. That way we can just say that an entity is named map, and we can just search for map and find the entity. So what we're going to do is first go into our entity.h, and here we're going to add a new field to our entity. We can just say that this field is a const char and an array of characters called name, and the size of this array, we are gonna define it up here. So we can just say max name length. We can give it whatever value we want. In my case, I'm gonna set it to 64, and we come down here, we put it here. It's giving me an error. Yeah, maybe this shouldn't be const. Oh, no, never mind. No, I'm just doing it the other way around. Sorry. I need to put it over here like this. Yeah, you can just like this. It's const. No, perfect. Now we have a field that can be changed called name, which is an array of characters. I set it to 64. You can set it to whatever you want, but don't go above this size, above 64 characters, because if you do, then your program is going to break. So take that into account. And now that we have that new field, we can just go into our entities.c. Okay, guys, just one small thing. Here, this can't be a const, otherwise it's going to give you an error when you try to compile. So let's change that, okay? Just remember that. Again, and create a function to find those entities by name. So what this function is going to return to us is an int, which is basically the current index of the entity. So we're gonna call the function find entity, and yeah, this seems correct. Yeah, what we do here is we pass a character. We're gonna pass it as const, so we are not able to change it. And what we're going to do here is just iterate through our entities array and use this function strcmp, which is basically a string compare. This function compares to strings. The first string is going to be the name of the index, like the current index entity, and then we are going to compare it to the name that we pass to the function. Then if this function returns 0, it means that both strings were the same. So what we want to do in that case is just return, and what we return is the index of that entity. In any other case, whether we don't find any entity with that name, what we want to return is a -1. So we know that if the function returns the -1, we didn't get a match. Now that we have that, we need to also copy the function and put it here in our, down here in our entity.h, and also we need to, very important, I forgot, we need to include our string.h, which is the provider of this function, strcmp, string compare. And yeah, that's about it. Now we can search for entities by name. So let's go into each entity and have a name for each one. So we have our camera, can come here and have a name, camera, and we can go into our map and do the same, name, map, and then our player too, name, player. Perfect. Now all of our entities have names and we can find them by their name. Now we just have one more thing left, and that's freeing memory, because we've been doing things and allocating memory, but I just didn't free any memory, so that's pretty bad. So what we're going to be doing is just freeing all the memory that we allocate. So in this case, for example, in our map.c, we allocate memory here with this function, and then we allocate memory for our texture type, and we load images. So we need to free all of that memory allocate here. So what we want to do now is just come up here and create a new function. We're gonna call it cleanup, the same way we call all of the cleanup functions in our entities. And in here, what we're going to do is first say that the cleanup function is cleanup here, and let's start freeing all the memory in our map.c. So first of all, let's free all of the textures. So here, if texture, we want to run the following code, whatever the code is. So let's delete this, I don't want it. So first of all, let's create this temp variable, storing the texture variable, and then run a while loop on this temp texture. So I don't know why am I waiting for the autocomplete to do things well. So what we're going to do inside of this while loop is just have a new variable. We're gonna call it next texture, and basically this is going to be the next texture in our linked list. And then after setting that, we want to have an if statement here. The temp texture, yeah, this is right. So let me just fill all of the function, and then after that I'm going to explain what each thing does. Perfect. And then after the while loop, we want to set the texture to null. Great. So what is happening here? First, we check if there's a texture variable that is not null. If that's the case, we run the following code. Perfect. The first thing is we have a pointer to the texture variable, and while this temp texture is not null, we run the following while loop, which basically does is first we assign a variable next texture to the next value of our linked list. Then we have an if statement checking if the current texture, the one that we're changing right now, in fact, I think that instead of temp texture, current texture would be a better name to make things more clear. So let's change it over here like this. So, and here and here. Yeah, this thing, I think it makes more sense to make things more clear. So if the current texture which is basically the SDL texture. It's so many texture. So if our current texture, SDL texture exists, we want to destroy it. So we access it and we destroy that. Then we free the memory from the current item in our linked list. And then what we make is that the current texture equals the next texture. And now after that, we would run out another iteration of our while loop. So if there's another texture, so a next texture in our linked list, this would run again and we would destroy the texture, free the memory, and go into the next item. And if there's no more texture in our linked list, this while loop would end and we would know that there's nothing left. We've freed all the memory, we've destroyed all the textures, and we're safe to just set the texture to be null. And after that, we just need to come here and say if map, which is the qtile map, exists, we want to use this function to free the memory for the map, qtile free map, and we pass the map as the argument. And then after that, we set the map to null. This way, we free all the memory that we allocated down here when we needed the map. So we are cleaning everything up. Then let's check all of the other entities and see if there's any more memory that we haven't freed. So here, camera, we don't allocate memory, so we don't need to free anything. Map, we've already done that. And then we have player.c. Here in player.c, we have one memory allocation that we have to free, and that's image load texture. If you check how image load works, we've done it in the map, but I'm gonna read it because I didn't read it before. When done with the return texture, the app should dispose of it with a call to SDL destroy texture. So what we've done here in map.c, and we're going to do the same. Let me just copy these 3 lines of code. We go back to player.c and we want to paste them here. So we just, oh no, perfect. And instead of this being a check in current on this, that not even here, we want to do this on the player texture, which is up here, and the same thing here. So if the player texture exists, which is basically an SDL texture, we destroy that texture, and that's it. We clear the memory. So perfect. Now we know that all of our entities are getting their memory freed after using them. And so from now on, I'll be more careful with memory allocations and freeing memory, because what you should usually do is how you should approach your software, especially on C, is when you allocate memory, knowing when and where you're going to deallocate that memory, because otherwise you're going to forget, and simply it's gonna cause many bugs, because you'll forget to free the memory if you don't do it just right after allocating it. So yeah, after that, I think we are done. Since we're on this miscellaneous episode, we can change this 30 to be a variable. We can call it static movement speed, and just set it to 3. Make this static as well, and let's move this over here. I just want to separate the things that are from outside. I'm not setting this to static because we want to have it as an extern. We have it here, extern position, but all of the other things are static. So let's have that. And yeah, maybe if I type the type, it would be nice. So perfect. Now we can just change all of the 30s to be movement speed. You can just do this. Perfect. Okay, and that should be all for today. So in the next episode, we'll be doing something for sure more interesting than this.